Finally, we get to our bonus question using the Ironwood database, right? So I'm just going to execute this, make sure I'm using Ironwood. Okay. All right, so we're going to do a stored procedure, student rank, USP student rank. Input parameter is the student ID, two output parameters, the full name of the student, first, middle, last, and the rank of the student. The rank will depend on how many grades above a C they've received. So the ranks will be gold, silver, bronze, etc., depending on how many grades they have. And then we'll do a test script, okay, as per the instructions. So I've just got a solution in here. We'll just kind of walk through it and we'll talk about the key parts. So it's going to be USP student rank. I have an input parameter, student ID. Why big int? Well, again, go back, university student. The primary key, the student ID, is a big int. So we want to make sure we choose the same size to match. The full name, why 63? Why not just 61? Well, the full name, we were asked to include the middle initial as well, right? So the first name could be 30. The last name could be 30. So those will be 60. We're hard coding a space between, okay? So that'd be 61. But if there is a middle initial, okay, then we're going to have the space, the middle initial, a period, and a space, right? That's 1, 2, 3 more characters, okay? So we could go up to 63 as the maximum number of characters if there is a middle initial. Now, it'll be less than that if there isn't, right? But we have to allow for the worst case scenario, so to speak. Not that it's a bad thing to have a middle initial, but you know what I mean, right? Okay, so it makes sense then, and you'd lose marks if you didn't choose an appropriate data size for the full name based on the expression we're using. Now, the data type for our other output, our student rank, okay, well, looking at the values it could be, the biggest is 6 characters, right? Nothing bigger than that, so that should do the job, okay? If you're really paranoid and made it a little bit bigger, I wouldn't penalize you, but it's not necessary. But I would penalize you if you didn't make it big enough. Okay. All right, let's go on then. Well, obviously, we need a variable to keep track when we count how many grades above a certain value we have, right? We're going to use the select to get the value for our full name, our output parameter. We can do that right away, concatenating together. Again, because the middle initial is nullable, right? Looking over here, it's nullable. We use the isNull function and just give an empty, okay, no character, basically, in between, right? Because we're adding on one space, first of all, so we don't want to add anything else if there's no middle initial. But if there is, it'll be the initial with a dot space, right? That's what's going to go after it before the last name. And that gives us our full name. And then our number, our variable, is going to just be count star. We just need to count the number of records, okay? Now the student is joined to the enrollment table, okay? And that's as per the design, right? So if to have a mark, there's a record in the enrollment table, okay? Where, okay, our where clause is important, where of course the student ID matches our input parameter, and I haven't revealed it yet. Coming up next, and, right? It has to be for this student, and we're going to count the records where the enrollment grade is in, right? And I have a whole list of the possible values. So the instruction said anything above a C. That would be C plus, B minus, etc., right up to A plus, right? So we only include grades higher than a C. So if the grade is anywhere in these, okay, now if it's still null, it won't be in there, right? And that grade wouldn't be included, so it wouldn't add to the count of how many grades that they've actually received above a C. So it's important we group by. Now we can't group by the expression, we have to group by the actual values. So the first name, last name, and the student middle initial, right? All the components that are being used to build the full name. And that would give us the correct result. Then for our select, we'll get the full name, we'll get the number, but then now we have another job to do. We have to decide which of these ranks we're going to return. And you could do that in a number of ways, but a nice simple way is a series of ifs, right? So if it's 0, it's coal. If it's 1, lead, 2, all the way up through. Now, if it's 3, silver, now it's going to be something bigger than 3, anything bigger than 3 will get gold, right? Doesn't matter how many, gold is the highest rank that they're going to get. And that way we have set the other output parameter, and away we go. Okay, so let's create this bonus stored procedure inside of our Ironwood database. Coming down here now for a test script, okay? We were given instructions for student IDs 1, 2, and 4, right? So I'm going to create my student ID variable. Variables to hold the name and the rank, right? Because we need to receive the output parameters. So here's my first test case for student ID 1. We'll execute, okay? We'll get the 2 output parameters, and I'm just going to use the select to output the values to the screen. Same thing for use case 2 and use case 3, which is actually student ID 4. Don't be confused with my use case number, my test case number, and the actual value that we're using to test. And that should give me the desired output, and I should see all the results that I'm expecting. And there we are. So student ID 1, silver, gold, and lead, right? Now, is it correct? Tell you what, I'm going to leave it to you to go to the data, manually go and look and see, but you should find that these are the correct ranks for those particular students based on the sample data we have in our database right now. And that, my friends, finally concludes exercise 8.